Guys, and welcome back to the channel. My name is Ty and I'm coming to you live from my mechanical room. As you can see right here, I have all of my mechanical system here, my furnace, my water tank, electrical panel, but I'm going to be adding something else to this room, and that is my network. So it's going to become my network room. I just moved into this brand new house, and I'm going to be making it smart. And one of the most important, or the foundation of every smart home, is a solid home network. In this video, I'm going to be showing you guys how I'm going to set up my network, what equipment I'm going to be using, and there are 4 considerations I'm going to be addressing throughout this video in my network. Number 1 is the wired, 2 wireless, 3 the equipment I'm going to be using, and 4 my network configuration and design. Now let's start out with the wireless component of this. When I was talking to builders to get my house built, one of the prerequisites was to allow me come in and install my low voltage wiring, because if I were to use the builders to do that, they were going to charge me off the ass for it, or they're not even going to be able to do it the way it should be done, because most of the time they have no clue what they're doing when it comes to smart technology. I mean, some of the equipment they even installed in the house that they claimed smart does not even connect to Wi-Fi or have an app. How could you possibly call that smart? So I was very livid when I moved into the house and I saw some things that they on the spec sheet wrote are smart, but didn't even have an app. Now I'll leave that for a future video talking about some of my experiences with this process. For the wired component, I came in during the build process and I installed Cat6 Ethernet cables throughout the house. Now, Cat6 is capable of up to 10 gig speeds, and the cable I used is Belden, which is plenum rated as well. So basically, in the case of fire, the cable is not going to act as a catalyst, so it's not going to carry the fire through the cable. Once the fire burns it just melts at that spot. When it comes to locations, I kind of just did common sense and best guess scenario, because you never truly know all of the spots you're going to need, because again, needs change and evolve over time. But I tried to use the most common places I know for sure I'm going to be using wired connections. So essentially every room got at least 2 Ethernet cables. Every TV spot as well got at least 3 Ethernet cables. And then every corner of my house also got Ethernet cables for my future security cameras, because I'm planning to use wired security cameras. I mean, I could also use wireless if I wanted as well, but the whole idea was to be able to plan ahead so that if I ever needed to change out stuff or use different equipment or devices down the line, I have that option as well. For my wireless access point, I've determined locations around the house that's ideal and optimal to be able to install wireless access points. The way wireless access points work is that they create a bubble. So when you take an access point and you mount it up to the ceiling, it creates a bubble around it. So you want to make sure that you are not directly stacking access points above each other on each level. So you want to kind of alternate them or stagger them. In my case, I kind of picked 5 or 6 spots across the entire house at different corners of the house. I'm not planning to use all of these spots, but depending on how my needs evolve over time, it's kind of nice to have those already pre-wired and just capped off. From all these 6 different locations, I'm going to pick the one that works the best, depending on my budget when it's time for me to buy more access points. For wireless, I'll also be using a wireless access point, and this will be wired. For those of you that don't want to go down this route, there are so many other solutions on the market, like the mesh system from Obi or the Linksys VLANs. Those will not be my first go-to, especially if you have the option of being able to add wire your wireless access points, because you get more reliable and consistent speeds with add wired connection versus a wireless connection. With the mesh network, you lose a lot of the speeds from just the communication protocol that those mesh networks use just to talk to each other alone, and then the other half is what you use for other devices. Another problem with this system is that wireless works in a half duplex mode, which means that only one device can communicate at a time. Unlike wired, you can have multiple devices talking at the same time, so they don't have to worry about taking turns. Now that's the most basic way to be able to explain that concept. Talking about my physical equipment setup, as you can see right here, I got this network rack. I bought it off of Facebook Marketplace. I'm going to be racking all of my equipment here. So everything is going to stay inside this rack and be nice and clean and tidy. And I keep everything into one space. One of the first things I did to this rack was to install caster wheels on them. I'm a big fan of putting wheels on every single thing. I like to be able to have things mobile so they're flexible. Say for example, I need to access the electrical panel down there. I don't have to worry about getting like 5 or 10 men to be able to carry this thing to push it over just to access my panel. With this guy, I can just kind of, roll it around, move it, and then I have access to my panel. I've also made sure that the cable slack from my Ethernet cable is also long enough such that I can be able to drag or roll that cabinet around the space. All of the Ethernet cables I run across the house, they all come back to this room and they consolidate and aggregate into this room. And what I'm going to be doing is I'm going to be using the patch panel. I'm going to terminate all those cables into a patch panel. And then from the patch panel, I'm going to use 1-foot cables to terminate it into a switch. So for my switch, I'll be using the Cisco 3750X. Now this switch is an enterprise level switch and it's a very old switch. I'm hoping to be able to replace this switch later on down the line with something from Unify, but the price point of Unify products are just outrageous right now. So this guy does the job for me as of right now. This guy works, it does PoE as well, which is power over Ethernet. So essentially what that means is that I can power a device as well as provide Ethernet connectivity to that device using just the one cable. So in the case of a PoE security camera, for example, which I'm going to be using outside of my home, I don't have to worry about having receptacles or outlets in those locations. The Ethernet cable will provide the power and the data to that security camera. And because the security camera is going to be streaming videos, I'm going to be getting more reliable and consistent connection and speeds to those security cameras. I'm going to be using the Unify access point. It's the U6LR. So basically Unify 6 long range, which means it supports Wi-Fi 6. And it will be getting powered over PoE as well from this switch. One of the things I like about the U6LR is that it supports Wi-Fi 6, not Wi-Fi 6E, because that's completely different, because I see a lot of people tend to confuse both of them together. I mean, a lot of you are quite familiar with 2.4 and 5. 2.4, you see almost all smart home devices use the 2.4 band, and that's because the antenna is actually cheap and very cost effective. So manufacturers would rather go this route to be able to keep the cost low for all their smart IoT devices. Also, 2.4 penetrates through walls and can go much farther. So depending on all the locations you need to install some of these sensors, switches, outlets, right? They might be far away from your primary wireless access point. So 2.4 seems like a logical and smart move to use. But one of the disadvantages of 2.4 is that it is, because it goes very far, it is also very susceptible to interference from your neighbors. So you can literally have your neighbors 5 or 6 houses down shoot their 2.4 and start, you open up your phone and you start to see their Wi-Fi SSIDs on your phone as well. Now that interferes and makes your Wi-Fi spectrum very dirty because they are also communicating at the same time, and your own communication and their own communication all comes together and just creates a messy communication link. Another limitation of 2.4 is that there's just 3 highways there, so they can only use 3 different links to be able to communicate on the Wi-Fi spectrum. But Wi-Fi 5 solves that problem because it comes with a lot more channel than just the 3. It comes with a whole lot more and it's faster. However, it doesn't go as far as 2.4, which is a blessing and a curse, because within your home you might need multiple access points to be able to get the coverage for Wi-Fi 5 across your entire house. Then you don't have the problem of your neighbors' Wi-Fi interfering with your own network because it doesn't go quite as far, so you have less interference. And transmission speed on 5 is also very fast. And then Wi-Fi 6. Wi-Fi 6 is not a new band. It basically just uses Wi-Fi 5 and aggregates some of those links together so you can transmit more data. The revolutionary and brand new one is Wi-Fi 6E because it creates completely new channel and band. You have fewer people using it because it's such a new Wi-Fi band and also very fast and uses a lot of the latest and the greatest in terms of technology. So you can get a lot more speeds out of it. However, you need to have devices that support Wi-Fi 6E. Devices right now that do support that are not very many, and the ones that do are usually very expensive. From a smart home perspective, you're not going to get any benefit from a Wi-Fi 6E. But again, the more of your devices that you can get off of the 2.4, the better for you, and then you leave the lower hanging fruit for the 2.4 instead. So in my case, that's what I'm going to be doing. I'm going to put as much devices as I can on my wired network, as much of them on the Wi-Fi 6, 5, and then leave whatever only supports 2.4 on the 2.4 band. Another important factor to consider for the rack is my power. I'm going to be using a UPS and an ATS. That is an uninterruptible power supply and an automatic transfer switch. Now the automatic transfer switch in my case would only act as a surge protector because I only have one power source. So if I had like multiple power sources and one of them goes down, it will automatically kick and switch over to the other power source. So basically zero downtime. The kicker for me is the UPS. A lot of times I'm always flipping up the breaker to be able to do things like replace switches. During this time period, it knocks down the power and then takes down the internet. But with my UPS, it's able to keep my network up and running. So people can still use the phones, laptops to be able to access the internet. Because remember, my Unify U6 LR is actually PoE powered from the switch that's also going to be in the rack. And then all my security cameras will still stay up and online as well. And in fact, network and internet will still be up throughout the entire time. Now this UPS is going to be able to provide power for up to 45 minutes. I can add more batteries to it to expand the time, but I think 45 minutes is more than enough time for me to be able to do what I need to do. In the case of a power outage, enough time for me to safely shut down all the equipment down there. Now this rack is also going to house a whole lot of other things. We were talking about my hubs, like my Philips Hue, my SmartThings hub, my Home Assistant hub, my Plex server. There's a whole lot more that will go in here. So this is why this is a central location for everything. Finally, for my network configuration, I'm going to be segregating all of my networks into VLANs. So that's basically virtual local area network. That way I can keep different traffics separately. So I'm going to break it down into IoT, my main network, and my guest network. My IoT network would be on its own. I would not be able to talk to any other network. My main network will be able to talk to my IoT network and my guest network. The main network is where my laptop and my personal phones will stay. No smart device is going to be on there besides my smartphone, of course. I'm going to use firewall rules to prevent traffic from going back from my IoT device into my main device. And the firewall would also protect or allow access from the main into my IoT device. Because again, IoT devices are notoriously not very secure because they come from a variety of different manufacturers from all over the world. And sometimes they don't care too much about the security. They just worry about mass producing this item. And they don't have too much to lose anyways, because most people don't even notice that there's a lot of security loopholes in the IoT network. So what I'm going to do is categorize all the IoT devices together. So even if someone gets into the IoT network, you can't access my personal data. The most you're going to be able to get is just my IoT devices. So no personal data will be able to be extracted, like my bank account or whatever, right? I mean, although your banks implement a lot of security policies in place to prevent that, but still, it's not infallible. A lady Googled her bank and then, the first address came up on Google and she clicked on it. It looked exactly like a bank's website. It was the BMO actually. It looked exactly the same. And she went in there, logged in, put in her username and password, and then immediately the attackers used something called the redirect. So it basically takes all of that information and then sends it off to them, and then the website immediately disappears and they were able to log into our account and do an e-transfer. In that case, even multi-factor authentication did not save her, because what happened was that when she logged in all those information, the attackers took that information and also went to the real website, punched it in to generate that OTP. So when he sent it off to her phone, then they also prompted her for that code. So when she typed in the code, they also take that code and go and punch it back into the real website. Even multi-factor authentication isn't infallible. So you have to take multiple measures to protect yourself and your family from cybersecurity attack, because trust me, it is a massive threat. So if you're going to go down the route of smart home, you have to be prepared to also take the responsibility of trying to protect yourself as much as possible. Now I am done racking all the equipment. I have my patch panel, I have my PoE switch, I have another PoE switch from Meraki. Now that's just something I'm using for testing. Using a tray as well, because the Meraki is not wide enough to support the 1U system. And then I've gone ahead and also racked my UDM Pro, my ATS, and my UPS. Now next thing now is to get them all connected. Now, one of the things I've done in terms of my ISP is to subscribe to a 1 gig upload and download speed from my service provider, and I've made sure that fiber was also installed from the outside of the house all the way to the comm room, so that I have fiber connection directly to my house. My service provider, which is Telos here in Canada, also has fiber optic cables ran all the way to their point of presence as well, which is in my neighborhood, and subsequently connects to my house as well using fiber. Essentially, I told him to install the minimum amount of equipment necessary, which is essentially the media converter. So what I essentially did is to convert their fiber into copper so that I can be able to connect my equipment into it. Now, one of the benefits of using my equipment versus using my service provider equipment is the fact that I have complete control over my equipment. Now I'm going to plug the uplink from their stuff to my equipment here, which is my UDM Pro. My UDM Pro supports 10 gig uplink, so I'm going to be connecting my UDM Pro to my switch using a 10 gig SFP. Alright, so my installation is finally completed. I've gone ahead and racked all of my network equipment, everything from my routers, my switches, my access points. I have also taken a couple of other things into consideration. I've installed an exhaust fan, so now this fan is going to help with cooling down my equipment. However, there are a couple of things that are still pending. I still have to install a smart switch in this room. I'm going to install a smoke detector. I'm going to install temperature sensor, humidity sensor, water leak sensor, essentially everything to kind of make sure that I am up to date on what's going on in this room. So immediately, if anything goes wrong, I will be immediately alerted to it. Now I'll be doing that in subsequent videos. Right now, I'm in the process of developing my basement. So this room is also actually getting some drywalls in there. It's going to get finished up as part of the basement development process. So I'm going to do all of that afterwards. Now, if you've been paying attention, you notice that I don't have labels on my patch panel. Yeah, this was a mistake I made when I was running the cables. At the time, I should have labeled all of these cables at that time, so that way I can kind of just transfer those labels onto my patch panel. But I was on a time crunch, so I couldn't get that done at the time. However, it's just a minor issue because I can actually find or know what each cables mean using something called the cable toner. Now, the way a cable toner works is that you plug one end in and then use the other end to kind of trace out or tone out the cable. So I'm going to be doing that. I'll plug the one end, which is my patch panel, which is done already, plug it in, and I'm going to use my cable toner on the field end, which would be wherever my security camera, TV, or any other spot is. Tone it at that time, mark it out, and then I'll kind of do it one at a time as I make my way through those locations. Eventually, when it's all done, I can now build out a label and then stick it on the patch panel. One other thing I didn't address in this video is my actual network configuration. If you'd like to see how to set that up, leave a comment down in the comment section and maybe I can make a video on how my network configuration is actually set up. Now that my network is all set up and good to go, now I can start to build on every other thing. So I'm going to start to install smart switches, sensors, cameras, everything else, because the foundation is ready to go. So stay tuned for all the other videos on all my other smart home stuff. And I'll catch you guys in the next video. Thank you guys for staying with me, and I'll catch you guys later. Peace.